Hello and welcome to day 9 of learning LeetCode from ChatGPT. So let's get started. So we're now going to have to do lesson 12 of the LeetCode curriculum. So let's see what we're going to install. Lesson 12. So are we still on linked lists? Oh, we're on recursion and backtracking. Oh, bit of Fibonacci and climbing stairs. Okay. So please give me lesson 12. Let's learn a bit about recursion and backtracking. So recursion is a technique where a function calls itself to solve small instances of a problem. It's powerful for breaking down complex problems into simpler subproblems. Understanding recursion involves grasping two main ideas. Base case, a condition where the recursive calls stop, preventing infinite recursion. Two, recursive call, the function calling itself with modified arguments that approach the base case. So the key concepts are the base case defines when the recursion should stop. So for example, in Fibonacci, like 0 is 1. You just return 1 to stop the recursion. Because when you have a base case, you don't return a call of that function. You just turn a solid number. Just an integer. Sorry, not this, just an integer. Without a recursion, we'll continue indefinitely causing an error. Yeah. So a recursive case reduces the problem in each call, so it eventually reaches the base case. Example, calculating Fibonacci numbers. The Fibonacci sequence is a classic example of recursion. Each Fibonacci number is the sum of the two preceding ones, typically defined as f0 equals 0, f1 equals 1. Okay, so you also probably need to hardcode the 1. Yeah, you definitely would, because, like, oh no, Fibonacci, I was getting confused with factorial. 0 and then 1 plus 0 is 1. I see. Well, n is less than or equal to 1, return n. Otherwise, we return Fibonacci of n minus 1 plus n minus 2. And so, yeah, we're going to need two numbers here. So, problem. Climbing stairs problem. Given n steps, you can climb either 1 or 2 at a time. Find the number of distinct ways to reach the top. Hint, the problem is similar to the Fibonacci sequences. Reaching each step can be done by climbing to the previous or the one before previous step. What? I'm going to just pick up climbing stairs problem. Actually, first I'll do the Fibonacci number. So that's quite a bit easier. So Fibonacci number leetcode. Fibonacci. Yeah. Let's see what we actually have. It says something about the nth number. Okay. So, is this the one it's just given us? So while n's less than or equal to 1, return n. Sorry, not while, if. I'm thinking a while loop. To be honest, we could just do it as a for loop. Can we Fibonacci or not? Just update a couple variables. Yeah, I'm going to do it as recursion, sorry. We're just going to return fib n minus 1 plus fib n minus 2. Run. Oof. So global name fib is not defined. What? How did ChatGPT do it? Is it going to be this dot? Is there this in? What if we do self instead of this? Over name. Okay, let me just see the solution. It's just a problem with. I'm gonna look up Python. Let's look at this one. Why is it doing two functions? Fibbo. Self.fibbo. Okay. I'm gonna get a different one. Easiest recursion logic. Is it maybe just a problem with that? Oh, it was. I see. Don't know what those other solutions were doing. Simply just do it like that. I see it's just self, not this. This is C++. Self is Python. Should know because of. Oh, only beats. Let's see. Memory complexity beats 68 because it's extremely little state. All we need is keep track of n. Well, actually, no. Recursion there's a lot of state involved actually because you've got to. Actually, but these can be instantiated or like expanded. Because you've got to know you get a function, a function, a function, a function. Yeah, and it gets very. So now I'm gonna look up the climbing stairs problem. Stairs, leetcode. Bing knows it. Climbing stairs, good old Bing. Okay, let's see how we get. So apparently it's going to be something to do with recursion, but it's apparently an easy one. So if you're climbing a staircase, it takes n steps to reach the top. Each time you can climb either 1 or 2 steps. How many distinct ways can you climb from the top? N steps to reach the top. There are 3 ways to climb to the top. 1, 1, 1. Okay, so we probably need some sort of array of array of lists, don't we? Like can we just do it in a loop? So while what was the ChatGPT's hint? So problems with overlapping. So hint, this problem is similar to the Fibonacci sequences. Reaching each step can be done by climbing from the previous one or the one before the previous step. To be honest, I'm not really getting what it means. So Fibonacci is in if n is equal to, well, we're gonna need another climb stairs 2. So it's gonna be n. There's also gonna be count maybe. And we're gonna have an R. Suppose we could climb stairs 2, n, 0, R. Self-dot. Okay, so climb stairs 2. So how are we gonna approach this? Saying something about Fibonacci. So what if we do if n is equal to 0, return R. Or what if we do self.r result.append But can we use state like that? I don't know. Let me go to the solution. Because I don't see how we would add in Fibonacci to it. All these emojis used. 80k. If climb is equal to 1. Oh, we're gonna do that. Okay. So 2 options are possible. Ah, I see. And then, oh my gosh, that's clever. Okay. So I just put it back to the description. So we're gonna create another function here, def climb. I'm gonna take in n. If n is equal to 1, we're just gonna return 1 because there's only one possible one. If n is equal to 2, return 2. Else, we're gonna return climb n minus 1 plus climb n minus 2, because this is gonna recursively call each one. So self. Is it, or is it just gonna be climb? Leave it like that for now. Climb n. Will this work? Because if it's 3, no, we don't need any more than that. So if you run this, I think there's going to be an error somewhere along the line with self-dot. Oh, it's accepted. Let's see if it accepts the submit test. Oh, time limit is exceeded. With 44. Yikes. Let's see back at the solution. How is this fitting the solution? Pure recursive can't pass the test case. Yeah, it doesn't work for a big number. Okay, I see. The second idea is use the dictionary to memorize repeating recursion. Ah, I see. So if we create dict dictionary equals dictionary at O. No, we're never gonna get to O. Equals 1. If you can't think of anything, just hash map it. It's always it was once in a lightning talk, C++ conference somewhere. Yeah, it's pretty funny. Okay, so we're gonna have that, and then we're gonna do if n in dictionary return dictionary n, and then we could just oh, okay, so we're just gonna do dictionary at n equals return dictionary at n, and let's see if this runs. Okay, let's see, does it work with the hash map basically? Oh, nice, it's 100%, but the memory complexity is a bit high. But we still yeah, we've still done it, and I don't know why I didn't think of the repeated recursion. But yeah, that's all for today's videos. Thank you for watching, and I'll see you in the next video. Goodbye.